So what we're going to discuss today, where does work management fit? We're going to talk about identifying, validating, and approving work, prioritizing work, planning work, scheduling work, executing work, analyze work and follow-up, measure work management performance, and manage resources and materials. So one of the things I wanted to start out with today is when we think about work management, you see it there in the middle of this pyramid. When we talk about all of the things that go into proper maintenance and reliability practice, you've seen this pillar in one of the you've seen this pyramid on one of the previous pillars where we talked about this, where I talked about organization and leadership being the foundation for everything. But work management is an essential part of maintenance and reliability performance. And with this graphic, I'm just going to show you briefly how these things kind of mutually support each other. So organization and leadership really supports work management by making sure that people know their roles and responsibilities, and by having the leadership team being attentive and assertive and making sure that people are following the right work management processes. We also need hierarchy, criticality, and configuration management to know what assets we have in the plant so that we know what items we're going to be doing work on. Once we have those, we can also look to equipment maintenance and reliability strategies. And those strategies feed back into the work management process in terms of what are the predictive maintenance or planned preventive maintenance tasks that we want to be doing. There's also an element of precision maintenance. How do we do things the right way? But equipment maintenance and reliability strategies also feed back into hierarchy, criticality, configuration management. Work management also fits into or also feeds into the proactive improvement processes that we have, so that as we identify things that can be improved, we can feed those back into the work management process. And some cases we also might need to change configuration, and we might need to change what the criticality is of certain assets. So as you can see, work management is central to everything we do within maintenance and reliability. What are the benefits of good work management processes and practices? Well, this is data that was provided by Winston Ledet from Ledet Enterprises many years ago. And if you look at this, looking at the status, the first level of the status is where an organization is doing preventive and predictive maintenance, but they don't have an effective planning and scheduling process, work management process. So in those cases, just by doing the PMs and PDMs, there was actually a minus 2.4% reduction in availability. In the second case, there was effective planning and scheduling, but no PMs and predictive maintenance. So there was an improvement in the efficiency on how the work team did their work. So in that case, there was about a 0.5% increase of availability. In the third case, where there was effective planning and scheduling with good PMs and PDMs, there was an order of magnitude increase to a 5% increase in availability. And then when you couple effective planning and scheduling, PM, PDM, and proactive reliability or proactive improvement, there was nearly a threefold increase over that base case. So when planning and scheduling are not controlled and stable, preventive and predictive maintenance reduces availability. That's kind of counterintuitive. But systems are taken offline for inefficient maintenance tasks, and tradesmen are under pressure to do repairs quickly. And that's where the problem is. So effective planning and scheduling reduces labor and material costs. The time spent by trade scoping, traveling, and time wasted can be drastically reduced. The storeroom stock can be reduced, and we can reduce expediting costs. So some of the benefits of good work management, things like the amount of labor hours that are scheduled, schedule compliance, and PM and PDM compliance can be increased. And this is just a case in point from a project that I worked on several years ago, where they had 18 different shops and zones, and we converted them to 5 areas and one group of central shops. And in this case, within the first year, with only about 40% of the organization converted to this program, they were saving over $1 million a year. You can see how when you put in an effective work management program, you can drastically increase a lot of the key metrics. So some additional things to look at here. This is a thing I call the Control and Stability Index. And I would say that most organizations fall between 0.2 and 0.65. This index is calculated by looking at the percent of workforce scheduled, the percent schedule compliance, and the percent of PM and PDM completion. When you multiply those percentages together, we get this Control and Stability Index. So most organizations are between 0.2 and 0.65 when you look at this initially. They can achieve scores of 0.68 to 0.82 within a year. And the largest rate of improvement is in that inflection point, or beyond that inflection point, where the Control and Stability Index values are between, say, 0.55 and 0.80. And so when you put in place a good, effective work management process, these are some of the results that you can see. And you can see on the vertical axis the percent of labor effectiveness. People might call that wrench time. That improves dramatically past that inflection point. So what's the basic work management process? That's where we identify work, we prioritize it, plan it, schedule it, then execute it and analyze it. But in this pillar 5, we're also going to discuss each of these steps in detail, but then we're going to touch on measuring work management and also briefly discussing planning and executing projects and the use of information technologies and the management of resources and materials. So let's dig into it. The first thing is about identifying work. So work identification has to follow a systematic process, and it should allow everyone to identify a problem or a task that requires action or resources. So in this little diagram here, identifying work can come from observations. So anybody in the plant can make an observation, and they can identify that some task needs to be performed. Now, it could be a high priority task or low priority task. That's for later on. But we need to know when people identify things, we need a method or procedure to be able to put that into that work category that's identified. We can also identify work from when we do preventive maintenance or condition monitoring tasks. By doing those tasks, we might identify defects in the assets, or ancillary things. When we're doing preventive maintenance, we might see something in adjacent equipment that we want to identify that work to be completed. And there's also partial or complete failures, of course. So when we have a failure, that is something we need to identify corrective action. Now, for me, I also say that when we're doing proactive improvement, so if we have people on our team that are being assigned to do root cause analysis or RCM, failure modes effects analysis, those types of proactive improvement type tasking, we should also capture their labor hours within the CMMS so that we're accounting for them. And likewise, if there's professional or personal development items, and even administrative or training items, it's a great way to capture those labor hours. So when we're identifying tasks or work, there's certain tools and processes. So some of the tools include using the CMMS or EAM. These are the systems that contain past, present, and future data on the assets, labor, parts, etc. And they can provide organization of information and measurement of activities. Work requests. This is a consistent format with required information for collecting information on requested work. We don't want people to give us all sorts of different varying information on the work request. We want a standard format that we require of all work requests. And then work orders. That's when we take the work request and say, yes, we're going to do this task. So that also needs to be a formatted task description that specifies the activities, resources, deliverables, and scope. It should have a basic input into the planning process. The processes that we use under Identify are that all incoming work orders must be submitted in a consistent way. So there's a procedure. Work request standardization. This is minimum required information. Work request validation criteria. What is required to accept the work request? Authorized personnel. Who has the acceptance authority? Who ensures that no duplicate work orders or work requests are already in the system? Work categorization. We should categorize work as preventive or condition monitoring, corrective maintenance, project work, and as I said, you can also use administrative training and personal development, other types of categorizations. Work request escalation. This is criteria for converting the work request to a work order. And then work group communication, providing feedback to the persons that requested the work request to be able to give them status. So if there was a duplicate work request already in the system, so their work request isn't going to be entered into as a work order, those sorts of things. Next, we talk about prioritize. So prioritization is a way to do classification. So we want to use, it's used for new or backlogged work. Prioritization should be fairly simple. And you should have a ranking system similar to this, where urgent work means do it immediately. Important work means do it within the next scheduling period. Routine work, do within the next 4 scheduling periods. And low priority is fill-in work. There's also asset criticality ranking. This is where severity, what will happen if the failure occurs? Cross-functional considerations such as safety, regulatory compliance, operational impact, maintenance costs, all those sorts of things should be considered when we talk about severity. What's the likelihood? What is the probability it will happen in the next month, quarter, year, 5 years? And then detectability. How likely can a defect or a warning sign be noticed? So prioritization classifications should be based on asset criticality criteria. And you can get a little bit more in depth on this by setting up matrices that help you to identify which are the schedule breakers, which are the planned and scheduled routine work orders and projects, and what work are the fill-in or low priority. And for those low priority, I always talk about adding an aging factor, because if there's a very simple task to be done, it will never float up to be planned and scheduled, because there's always more work to do than we have resources to do it. But if we don't adhere to a good prioritization system, then the people that submit work requests will try to make everything sound like it's an emergency, that it has to be dealt with now. So if you put an aging factor in place, you can basically add points to these low priority work requests so that over time they float up and eventually get plugged in and they can be performed or executed. So some of the tools for prioritizing, as we said, asset criticality evaluation, looking at the production schedules, identifying safety and regulatory requirements, using a prioritization model such as one found in ISO 14224, where we consider operational, safety, environmental, single point of failure, maintainability, and reliability. Also things like spares lead time. We can also apply reliability-centered maintenance or failure modes effects analysis or failure modes effects and criticality analysis of the most critical assets. These will help us to prioritize what the priority is of different assets and failures. There should be a prioritization process, and that means having a documented and plant-wide authorized process for prioritization. We want to publish and train all personnel on that process. There should be criticality assessment process as well. identified work prioritization process, and that ranking index for maintenance expenditures should have a work ranking. An audit process. We need to be attentive. We need to notice compliance and non-compliance with these processes. We also need to be assertive. We need to appreciate compliance, and we also need to address non-compliance. And there inevitably will be outliers. And when we have an outlier, we have to have a procedure on how to review the work requests that don't fit into the prioritization scheme. Who's accountable or who has the authority to make a decision on those outliers. So next, let's talk about planning the work. So the planner's job is to optimize the workforce productivity and work quality by planning and coordinating labor, materials, equipment access, etc. To do this, planners develop job packages. These include procedures, references, materials, tools, equipment, parts, permits, etc. So the planner needs to review the work order, perform a field check, prepare or modify existing job plans, prepare the craftsman's job package, the parts, equipment, permits, etc., and forward the completed job package for scheduling. Gather the craftsperson's feedback after the job is completed. Update and save the job plan to the job plan library. Now, I'll also say that there are many minor tasks and things like preventive and condition monitoring tasks that may not require a full formal job plan, but they may still require parts and other planned items. So they can more quickly go through the planning process. So when we talk about planning the work, the tools and processes, of course, the CMMS or EAM. Estimating guides. So you should allow plenty of time for precision maintenance practices. The planner's job should not be to get jobs done in the minimum time possible. It should go to the minimum time required to do a precision maintenance and repair job. We should make sure that we allocate time for safety procedures, lockout, tagout, confined space, hot work, working aloft. A lot of these require setup and additional personnel as observers. Planning and scheduling software if it's not included within the CMMS. Tech manuals, machinist handbook, industry standards. These are all tools that the planner uses. The job plan library. So if we planned a job once and there's a similar piece of equipment, we don't want to reinvent the wheel every time we have a work order that requires a job plan. We should establish a job plan library where we can archive them. And then measures. We want to use tools as measures to look at the actual versus the estimated time that we put on the job plan. How accurate was the parts list? How much time it takes to plan the job. We should be looking at these measures and always working to continually improve. On the process side, we need well-defined planning and scheduling process. We need work identification prioritization. We need work scope procedures, a standard format for capturing the scope, for breaking down task steps, for identifying parts and the types of labor, etc. There should be a procedure for adding job plans to the job plan library. And that library of procedures. By that, with the library of procedures, so if there are procedures on things like how do you properly do precision alignment on rotating equipment, we don't have to, within the job, the work order, we don't want to list those task steps. We want to reference a procedure so that they can pull up, the workforce can pull up the procedure, and we don't have to duplicate those activities within the work order. We can just reference them. And again, bill of materials and parts usage data, that should help us to feed the MRO stores and what's the max minimum levels that we should be setting and all those sorts of things. Now we talk about scheduling the work. The purpose of work, the labor schedules to balance resources, to minimize the effect of break-in work, to coordinate parts, materials, and shared equipment. So making sure that resources are available at the right time. Labor schedules determine the type and quantity of the labor available. So a shop supervisor should be looking forward to next week to identify who's on vacation, who's on light duty, what skilled trades do I have available, and how many total hours do I have available. That's feedback that the scheduler needs. Production schedules also determine access to equipment without disrupting production. We should know what systems or lines are going to be down during next week or in the scheduling horizon. We want prioritization of tasks that minimize break-in work effects. So what a lot of organizations do is they will look at the number of tasks that are going to be worked that week and assign the lower priority tasks to a handful of people that are going to be the people that you break off of the jobs to address the break-in work. So you try to get your PMs and condition monitoring tasks as a high priority, and you don't break schedule for those, but you break schedule for the little jobs that maybe came up on the aging factor. We also want to try to kit parts, materials, and be able to identify shared equipment that we can assign to the task during the hours that the task should be getting done. And that should help us to minimize idle time and travel time, walking back and forth to obtain the materials and the equipment and tools. Scheduling should only happen for planned work when all the planned items are identified and confirmed. So we don't want to say, yeah, we think the delivery is going to come in time to do this task. We want to confirm that the materials, parts, tools, etc. are available so that when it's scheduled, it's going to go off without a hitch. So some other things on scheduling the work. Backlog management. So we want to have those items that have been through the planning process that go into ready to schedule. All the known work that has been through the planning process, detailed or simple job plans. As I said earlier, some jobs, some tasks don't require a detailed job plan. We can refer to those as simple job plans, but they still should go through the planning process. Who will do the work and when the planned activities are to be carried out? That depends on commitments from each of the work centers, maintenance, operations, even contractors that are supporting your work efforts. Tradesperson's skill sets and qualifications and available work hours define the workforce loading and volume of work orders to be accomplished. Shutdown, turnaround, and outage plans. These can also be used to bundle work orders for scheduled downtime periods. Planning identifies and ensures materials, equipment, tools, permits, etc. are available, but scheduling determines when they're going to be required. Preventive and condition monitoring tasks typically must be performed at known intervals. And these should be the first items scheduled and the last ones that you break the schedule for. So this always brings up a question on scheduling. People ask, well, if we only expect to get 80% of scheduled work completed, as that's, top performance, should we schedule 100% of the workforce? My answer to that is I believe you should. I believe you should schedule 100% of the available hours because you're then able to compare that to a standard. If you only do 80% and keep 20% back as a flyaway team or a do-it-now type team, then we're not sure that we're going to be able to utilize all of the hours available. There's differing opinions on that, but that's my feeling. So some of the tools and processes for scheduling the work. Again, we need production schedules. We need to know what the workforce schedules are. We need to have planned work that's ready to schedule. there should be weekly planning meetings. Now, if you're in a reactive mode and you haven't yet put in place good planning and scheduling, your scheduling horizon may only be a one-day scheduling horizon, but over time, it's best to try to get it out to weekly planning and scheduling meetings so that you know what you're going to be doing next week instead of what we're going to do tomorrow. But it takes time to get there. Daily schedule status updates. So if certain jobs were supposed to be done on a particular day and there was, something to do with production schedules, for instance, that you needed to have this task done, well, we want to make sure we're keeping everybody informed. So there should be some form of daily schedule status updates. Measures, things like percent of workforce scheduled, schedule compliance, the percentage of PM and condition monitoring tasks that were completed on schedule. These are all great measures. We also should have some planning and scheduling software. A lot of the CMMS tools allow you to do that within the tool. But in other cases, you might have to use a tool like Primavera or Excel to keep up on the planning and scheduling aspects. Estimating guides. They should be locally developed based on history, but you can also use industry guides. Equipment and special tools management. This is important where there's shared equipment or special tools that need to be set aside for tasks that are scheduled. On the processes side, we obviously need planning process. So that way we are able to estimate the labor, materials, permits, etc., and have those provided and ready to go. We need workload and work center matching. So balancing the availability with resources required to accomplish the work. And again, as I mentioned earlier, the big question of whether we schedule to 100% or 80% of loading. As I said, my preference is to the 100%, but whichever one you use, build it into your processes and procedures so that there's a standard that people know what they need to comply to. Ready to schedule prioritization. So as I said, my belief is that preventive maintenance and condition monitoring need to be a very high priority. They should be the first thing on the schedule and the last thing that you break schedule on. There should be a scoring procedure to select the most appropriate scheduling candidates. Low priority, ready to schedule should have an aging factor so that you can ensure that they eventually will get done. And again, weekly planning processes should be a mandatory meeting for key maintenance operations and support decision makers. It sets the schedule for the next scheduled period, whether that's a 1 day, 4 day, week, whatever that scheduling period may be. And they should also be discussing the previous schedule issues, what didn't get done during the current scheduling period, and where it's going to fit onto the next scheduling period. Next, we talk about executing the work. So this is applying labor, materials, tools, equipment, and services to perform work with precision as efficiently as possible while conforming with environmental health and safety requirements. Within the work management process, we want to define how scheduled work orders are assigned to individual tradespersons. We want the organization and leadership, how organization and leadership is used to manage productivity in environmental health and safety compliance. Leaders must support their team members to ensure that they can do high quality work. So there must be adequate resourcing and time allocations that are needed to ensure that the capability to perform precision work. Use position and authority to resist pressure to deviate from precision work. That takes fortitude, and I know it's not easy, but that's what we should be striving to do. So the tools that we use for executing the work, once again, the CMMS or EAM. We should include an archive of precision maintenance procedures for reference. As I said earlier, we should have a library of procedures. and all of the precision maintenance procedures should be part of that library. We want the ability to document start and completion dates and times, adding notes. We want to confirm the parts that were used. Work order templates, so tradespersons and others know where to look for important information about the work order. What are the safety precautions? What sorts of PPE are required? Those sorts of things. Where do you look on a standardized work order template? Work packages of kitted parts, permits, reserved equipment, and special tools. We want quality assurance and quality control practices for maintenance and repair and commissioning and validation. We want well-defined and compliance with permit and safety program requirements. Things like confined space, lockout, tagout, hot work, working aloft, etc. Skills assessment and training program. Training should be provided to close position description skills gaps. And we talked about that in one of the previous pillars. Additional training to develop additional skills, so professional development. And there should be attentiveness and assertiveness among the supervisors to make sure that the work is executed as it should be, with precision and in the minimum time required to do a precision job. Now we move on to documenting the work. Accurate, detailed documentation will provide information on resource utilization, information for continuous improvement of the planning and scheduling process, and equipment reliability strategies, as well as the actual labor, materials, and contractor costs and system downtime. So the work management system is the focus of the CMMS or EAM. Condition found remarks are important for confirming failure modes and effects. Planned versus actual labor hours, materials, contractor costs, etc., help to develop more accurate budget projections and better work order planning and scheduling. As found and as left conditions can be used for repair or replace decisions, for shutdown and turnaround planning, and for capital project planning. And measuring points such as run hour meters or cycle counters can be used for interval-based maintenance procedures and reliability measures, things like mean time between failure and mean time to failure. So some of the tools and processes we use to document the work, of course, here we go again with CMMS and EAM. This becomes the repository for all asset, work order, and procedure documentation. The work orders, the primary means to state what is required and to document what was found and what was done. Bill of material and inventory stores. This is the means to identify parts and sub-assemblies that are going to be required. Failure reporting. This confirms or refines failure modes and effects. We can look at certain levels of damage, the cause of that damage, and remedy codes. Document control. This is often overlooked, but there should be processes and procedures, and we should make sure that the ones that are in effect, the ones that have been authorized, are the most current ones that are available to everybody. Configuration management. So systems in the field should match the documentation, the P&ID drawings and the parts and bill of materials that are in the CMMS. Inventory is aligned with that configuration. So if we've got dead stock, parts that are no longer used for any of the equipment in our plant, we should get rid of those materials. And likewise, if there are equipment in the plant that require materials that we should have in stores, we want to know about that. On the process side, there should be a post-work documentation process. What was the reason for repair? What corrective actions were taken? What component failures were noted? What are the indications, are there indications of process, operation, or other contributing factors Things like if the assets were exposed to weather, is there a way that we can help protect those assets? So what are the indications of failure? A warranty period review. Identifying skills or training gaps. So if we have a lot of belt failures on belt-driven equipment, maybe we need training on how to properly install matched belt sets. Work management. So again, the planning and scheduling strengths and weaknesses. What could have been done better? We also want to maintain history. So equipment maintenance history can be used for life cycle costing, for ROI calculations, Pareto analysis to identify the bad actor list, for process improvements and safety procedure improvements. And of course, we want to also use that history for repair, replace decisions, and we can also look at the percent of RAV calculations, etc. Now let's talk about analyzing and following up. We don't collect work order data just to collect work order data. We must compare the actual performance with planned performance. So job plan analysis and improvement. We want to reduce or eliminate inconsistencies and increase quality. We want standardization. We want to identify all elements that led to precision maintenance, increased reliability, safety, and regulatory compliance. Equipment reliability analysis and improvement. It needs to be based on work order data. Is the equipment reliability improving? Identify assets that are bad actors or getting worse or getting better. If they're getting better, that means when we go back at the original step of prioritizing work, that criticality, asset criticality ranking may change. If the equipment gets more reliable, the criticality may drop down a bit. Cost analysis and improvement. The total cost per unit produced or the maintenance cost per unit produced. Be careful not to optimize maintenance costs while also increasing total cost or reducing OEE. And that's really when we should be doing a PMO, preventive maintenance optimization, getting rid of tasks that don't add value but consume resources. So some of the tools and processes we use for analyzing and following up, of course, the work order data. The more accurate it is, the more valuable that data is. The equipment history, mean time between failure and mean time to repair. Maintenance cost data, the labor, materials, and contractor costs. Availability. Pareto analysis, so we can come up with that bad actor list. We may also have a tool by using benchmark data. Look at other plants in the same company. Look at competitors with similar products or services. FMECA and RCM. We're always looking to eliminate ambiguities, gaps, or overlaps in equipment reliability strategies. Root cause analysis. This tends to be more of a holistic analysis of management guidance, assets, human error, etc. On the process side, we should have processes for comparison, comparing current work orders versus historic work order patterns, comparison of benchmarking cost data with current work order performance, identify variances, work management metrics, equipment PM and condition monitoring compliance, and others. Towards the end of this presentation, I've got 2 slides full of the measures or metrics that we can look at. I'm not going to go over those in detail, but I just present them so that you can go through them at a later date. Updating job plans. We want to improve the quality of our job plans all the time. We want to reduce or eliminate variances on how tasks are completed. And preventive maintenance optimization, we want to also review and update resource requirements. Review and update materials management. So now let's talk about measuring the work management process. So it's important to measure performance of the work management process to determine if the current state of performance, to identify gaps between the current and expected performance, and to develop the necessary improvements. So performance measurement and management, quality management, leading and lagging measures, and work management process effectiveness. The tools and processes we use to measure work management, again, the CMMS or EAM system, the repository of the data that all of the work management process resides. Work management metrics. So we want to use measures for managing the work request and work orders. For instance, how long, once the work request has been identified, how long does it take to convert a work request to a work order? Then how long has the work order sat in the backlog waiting to be planned? What's the average planning time per work order? What's the average time that ready to schedule work takes to actually be scheduled? And you can do these all based on the prioritization or the criticality of the assets. We can establish target values for all of these work management process measures. And we can have a scorecard that tells us how we're doing on the key metrics. Dashboards can be used to keep other people informed, not just for the planner and scheduler, but also for the customers, the people that are expecting, that have put in work requests. They want to know how long it's taking for the typical work order to work its way through the process. Inputs and status review meetings. So sometimes things change. A work request may have been submitted under certain circumstances, but the circumstances may have changed. So we want to have periodic review meetings to make sure that things are prioritized correctly. See lists of metrics on the next slides, as I was mentioning earlier. Work management process gap analysis. We want to identify and implement improvements to the work management process. On the process side, the work management process assessment. So what are the things that we're looking at? What should our, for a priority 2 item, how long should it be in the backlog? How long should it take for it to get through the planning process? How long should it take for getting through the scheduling process? Those sorts of things. And there can be monthly or quarterly to semi-annual and annual. All depends on the maturity of your work management program. If you've just implemented it, then that assessment should be done more frequently. But as the culture changes, as people start following the processes and procedures correctly, that assessment can be elongated, can go out to quarterly, semi-annual, or annual. Performance measurement and management. Communications with leadership. We want to identify or confirm priorities and periodically review them. We want to solicit support for compliance. And we want to also have a continuous improvement process. So we want to identify the strengths, weaknesses, and opportunities and threats in our work management process. We want to assess and define responses. And we want to authorize and implement improvements. So now let's talk just a moment about planning and executing projects as opposed to work orders. So maintenance professionals must understand all aspects of capital project management. Project management includes initiating, looking at the business case, the capital project requirements, the design and the contracting, but also project planning, project scheduling, resource management, monitoring and controlling project activities, managing risk, supervising project progression, communicating, validating, accepting, rejecting deliverables, and archiving project information and data and documentation. Project phases and life cycles are, we need to be doing this over all the project phases and life cycles. We should be able to manage a project team. And we should be cognizant of the life cycle costs of the project and the contract management, making sure that we're adhering to contract laws and making sure that we're adhering to whatever your organization's contract management processes and principles are, policies. So some of the tools and processes: estimating job packages and costs. We use things like work breakdown structures, historical data, and there's commercial sources available, things like RS Means. There's project management tools, and these include things like Program Evaluation Review Technique, or PERT, Critical Path Management Method, Gantt charts. We also need to do risk analysis, project management metrics. We use project management software. These are things like Microsoft Project, Primavera, or just simple spreadsheets. On the process side, there should be a business case justification for the capital project. Remember Pillar 1 in business and management, we talked about that extensively. Project requirements development, contractor selection and management. There should be processes for project scheduling, design, contracting, fabrication, installation, and commissioning. We should also look at labor, the work breakdown structure during job phases, and all of the interdependencies, so we know what are the long poles of the tent, what are the critical path. We should have processes for operational and control procedures, approval authorities, support and information notifications, and project supervision processes. So what reports and metrics do we need to be able to produce? Management information system and documentation processes, risk management processes, and project closeout processes. And here we're talking about using IT effectively. So we need to be leveraging the capabilities of data historians, process control systems, condition monitoring software, CMMS, EAM data, etc. So we need to develop an information management policy and processes. We need to apply technology for documenting and record keeping. We need to leverage data management functions within the CMMS or EAM. And we need to apply preventive and condition monitoring information technology correctly. Integrate process and equipment monitoring capabilities. Some of the effective using IT effectively tools and processes, again, CMMS, EAM, document control and management software, simulation and CAD software, project management software, human machine interface software, SCADA or data historian software, work management metrics, project management metrics. And on the process side, there should be a process for document management, a process for equipment history and bill of materials data management, work control processes, the entire planning and scheduling process, interfaces with accounting and personnel and materials management software. These can greatly improve the efficiency of how you integrate your IT systems when there's good interfaces between accounting, personnel, and materials management. Process safety management. We also need processes for data analytics. Often overlooked, things like calibration and inspection management, and version controls for PLCs and other instruments and other software applications. How often have you seen a PLC system that had outdated software? And finally, managing resources and materials. The maintenance function should identify what to buy, when to buy, who to buy from, and what to keep in stock, and what inventory should be eliminated. There must be effective control of the storeroom and inventory related costs, while maintaining expected service levels. There must be accurate documentation of the equipment components and parts in the CMMS, along with recording information after completion of maintenance activities. We're concerned with critical equipment and critical spare parts, materials and resource demand forecasting, bill of material, equipment spare parts, where used and in what quantities. Inventory management, things like the maximum and minimum inventory levels. What's the shelf life? What's the proper organization and storage of those materials? And what's the life cycle analysis? There's an initial cost, a service life, holding costs, and disposal costs. We need to know what those are. And procurement, issuance, restocking, rationalization, and disposal processes. So when you look at the tools and processes under this category, things like storeroom ABC analysis. What percentage of stock are highly critical? Which are consumables that we use a lot of? How many inventory, based on inventory turns and costs? Spare parts criticality analysis. Another tool is demand forecast analysis. So manufacturing resource planning and how much PM, PDM, level of repair work that we do, those should all be inputs into the demand forecast. Materials requirement planning. There can be automatic replenishment when your stock system falls below the minimum storage level. It may auto order those materials. There's something called economic order quantities. So based on your suppliers, if you order in certain quantities, you may get discounts. So the trade-off between what your holding costs are, what your other costs are, your usage levels, there's a way to determine what is the economic order quantity. Standardization. We want to standardize on things like PLCs and motors so that we can get economy of scale. We can buy more of one product instead of buying a little bit of several products. Supplier selection criteria. Parts and kitting. Another tool is storeroom KPIs. So we want to know things like inventory turns for categories of parts. What's the service level? So when a part is requested, what's the percentage of time that that requested part is available? Cycle counting for inventory accuracy. On the process side, what part or equipment specifications do we have? Quality versus cost, OEM standardization, storage conditions and requirements, inventory control processes, adding and deleting inventory items, the max-min levels, access during shift hours and off-shift hours, vendor stocking contract management, lifecycle cost processes. So the initial costs, the annual holding and carrying costs, the rationalization of dead stock, and work order parts kitting processes. So again, this slide and the next one are just a listing of various metrics that should be considered when talking about work management. And this is just the wrap-up slide. What did we discuss today? Where does work management fit in? Identifying, validating, and approving work, prioritizing work, planning work, scheduling work, executing, analyzing work and follow-up, measuring work management performance, and managing resources and